Hey there, Mr. Weaver here, and this is Topic 6, Lesson 3, Features of Exponential Function. After this lesson, you need to be able to identify the features of exponential functions from a graph. You'll know you're successful after this lesson if you can identify the features of exponentials, including domain, range, the asymptote, the y-intercept, and the common ratio. The first feature of an exponential function is domain, and we have seen this word before. The domain is the x values for the function. It's the input. For exponential functions, your domain is always going to be all real numbers, which means that it can go from negative infinity all the way to positive infinity, and we can have any x value in between. We can take any x value and plug it into our function. The range, we've seen this word before as well. It is the y values for the function, or our output. Now, our range depends on our next vocab word, which is our asymptote. An asymptote is an imaginary line that the function approaches but doesn't actually meet. So the function's getting closer and closer to it, but it never actually touches. So here we're going to be dealing with some horizontal asymptotes, where if our function looks like this, our asymptote is going to be an imaginary line where it's getting closer and closer to, but doesn't get there. So that pink dashed line there is our asymptote. We can see the function's getting closer and closer to it on the bottom. And the asymptote is going to be written as y equals a number. Many times it will be 0, but you do need to double check with the graph. Going back to the range, it depends on that value that we get for the asymptote. So wherever our asymptote is, if the graph is above the asymptote, then our range is going to be y is greater than the same number as the asymptote. If the graph is below the asymptote, then your range will be y is less than that number. We'll see how this works when we look at the graph. Next, we have our constant ratio, the value that you're multiplying by each time in the exponential function. It's also called the common ratio. I will probably refer it more with common ratio than constant. In exponential functions, there is a specific formula for how they are written. So the basis of the formula is f of x equals a times b to the x. In this situation, a is your start value, and b is our constant or common ratio. It's going to have two numbers, and almost always will be written in this format. F of x equals a number times a number to the x power. That x power stays as an x when we're writing our formula. Finally, we have our y-intercept. This is the y value when x equals 0, the same as it was when we dealt with linear functions. It's the place where the function crosses the y-axis. In exponential functions, however, the y-intercept is your start value or your initial value. It is a. So a is going to be your y-intercept, b is your common ratio, and together they make your exponential function. Let's put this all together and identify our features from our graph. So first, let's start with our initial value. This is the y-intercept, or where it crosses the y-axis. On this graph, it's where the red arrow is pointing. What number is that? Well, it's not counting up by ones, because it counts up 1, 2, 3, 4 spaces to get to 60. 60 divided by 4 means we're counting up by 15s. So our initial value was at 15. So I'm going to write that as my initial value. To figure out the common ratio, we need to determine what was being multiplied by to go from one point to the next. My next value is 30. After that, I have 60, 120, and 240, which means each time it is being multiplied by 2. So our common ratio must be 2. Using those two things together, we can write our function. So f of x equals 15, our initial value, times 2, our common ratio, to the x power. Remember, when you're writing a function, start it with f of x equals. And then notice the x is in our function. It is still to the x power. That's part of an exponential function. X is in the exponent. Next, let's identify our domain, range, and asymptote. So our domain is all real numbers. Again, it's always going to be all real numbers for these types of function because we can plug in any value we want for x. Our range depends on the asymptote, so let's find our asymptote next. Well, if we notice, going backward, it is getting closer and closer to 0. If you're not sure about this, follow the pattern backward. So from 60 to 30, it would be dividing by 2, to 15 divided by 2. Divided by 2 again would be 7.5. Divide by 2 again, we'd get 3.75, and then 1.875, 0.9375. It's getting closer and closer to 0, but it's not going to go negative because just dividing by a positive number can't make it go negative. So our asymptote would be y equals 0. And then where is our graph? The graph is above that line. So our range must be y is greater than 0. And there's all of our features that we can tell from this graph. Now it's your turn. Pause the video, look at the graph, see how many of the features you can identify. Go back and watch part of the video on the last example if you need a refresher on where to look for things. Check your answers. Our initial value should have been 20. Common ratio was 3. So your function should have been f of x equals 20 times 3 to the x power. Domain, all real numbers. Asymptote was y equals 0, so the range was y is greater than 0. Here's the graph showing where we can find each thing. Pause the video again if you need time to look through where each number comes from. Let's look at a slightly different type of graph. If you notice, this one started off a little bit higher up, but is going down each time. Even though the graph looks slightly different, everything is pretty much in the same spot. So our initial value, where we cross the y-axis, our y-intercept, is at 20. What's happening to it each time? It went 10, 5, 2.5, 1.25. You may notice that we are dividing by 2, and you may be tempted to write divide by 2. However, the formula for our function is a times b to the x power. So we need to figure out what we multiplied by to go from one thing to the next. Well, multiplying by 1/2 is the same as dividing by 2. We multiplied by half again. So my common ratio is 0.5, or I could have written the fraction of 1/2. Using those two numbers, my function f of x equals 20 times 0.5 to the x power. Domain, again, all real numbers. Asymptote, it is getting smaller and smaller and smaller, but it's still getting closer to 0. It won't go negative. If you don't believe me, take a calculator and keep multiplying by 1/2. See if you can ever go negative. So your asymptote, y equals 0. And again, our graph is above the line. So your range is y is greater than 0. Your turn once again. Pause the video, look at the graph, and identify the features. Check your answers. Look at the graph if you need to see where each number comes from. Pause the video again if you need more time to look at the graph. In our examples, we only saw things where our range was positive, where our graph was above our asymptote. But that's not necessarily how it will always look. On the left, we can see our asymptote is still at y equals 0, but this time the graph is below the line. So this would mean that our range would be y is less than 0. On the right, this time our asymptote, here's an example where it does not flatten out at y equals 0. It flattens out 1, 2, 3, 4 units down. So at y equals -4. This time, if you notice, the graph is still below, but our range is y is less than -4. So whatever the number was for the asymptote, that's the same number for the range. All of our previous examples were 0, but just know it could be another number. In this lesson, we learned that there are features of exponential functions that we can tell from a graph, and each feature can tell us something about the function. The y-intercept, or our initial value, tells where the function starts. The common ratio tells how the function's changing over time, so what it's being multiplied by. The asymptote tells the highest or lowest point that the function will ever get, although it never actually gets to this value. The domain tells us what x values that we can put into the function, and these functions we can put in all of the real numbers. And our range tells us what numbers that we can get out of the function. And the range is based on where the graph is above or below our asymptote. When we start looking at some word problems in context, each of these features will help us determine what the problem is actually saying and what it means in real life. After this lesson, do you now know how to identify the features of exponentials, including domain, range, the asymptote, the y-intercept, and our common ratio? If you're not sure about these things, go back and look through some of the examples, noting the colors of the matching features and where things are located each time. And that's the end of Lesson 3 on identifying features of exponential functions.